All right, guys, this is going to be a fun one. We're going to be talking about points, lines, and planes, how they're related, what they are, what they're not, and a few vocabulary words. Hopefully by the end of it, you can define all the words on this screen and maybe a little bit more. But let's get into it. So we have a 3D graph here, and we can kind of see what's going on. There's a gray plane that's drawn for us, and we can rotate it and look all around. What I'm going to do is I'm going to put a point on the plane. Boop. I can put it anywhere I want. Once it's on the plane, I can move it anywhere on the plane I want. So notice how it stays on that gray plane. That's 1 point. A point is just an exact location in space. It's just a single spot in space. It's not a thing, it's a place. It's represented by a dot and a capital letter. So points, not much to it. Single place in space. Points are all over the place. I could draw infinite points on this screen if I wanted to. But my first question is, how many lines go through a point? So to do that, to show you, I'm going to put a second point on the screen here. And my question is, how many lines can go through point A? I'm going to connect B to A with my line tool. All right, right now, do you see the one line? There's one line that connects B to A, right? One single line. The thing is, I could put B anywhere I want and it would still connect to A. Isn't that pretty cool? So it does not matter where B is. So I'm going to take point B, I'm going to move it around. Can't it connect to point A no matter where I put it? Even if I raise it above the plane. So point B, check it out, it's above the plane. And it's still connected to A. So it does not matter what direction I come from. B can connect to A with a line. B could be anywhere in the universe. So what that means is that there's an infinite number of lines that go through point A. So if I just said, hey guys, line A, do you see it? You would have to say no. There is no line A. There are infinite lines that go through A. So how do you name a line? You don't call it line A. You would have to say, in this case, line AB. Well, how many line ABs are there? There's only one line AB, right? I move it, it's a different line now, but B had to move for that to happen. But if B was sitting still, which on a piece of paper normally it is, I can manipulate this. But normally B is not moving around. How many lines can hit A and B? The answer is only one. It takes 2 points to determine which line you're talking about. So when you name lines, you're going to name them with 2 points. So like line AB is a line that hits both A and B. You would never say just line A or capital A. So this means line AB. This means point A. A single capital letter is a point, not a line. So you name a line with 2 points. Would you say A and B are collinear? Collinear. Just think about what that means. Collinear. Co means it like you share it, like captains share the captain duties. Collinear, they share. Linear, line, linear, the word line's in it. They share a line. So B and A, do they share a line? Yeah, the answer is yes, they do share a line. They are on a line together. As a matter of fact, it doesn't matter what 2 points I pick, they will share a line. 2 points are always collinear. So let's put a third point over here, point C. Are A and C collinear? Now, it's not is a line drawn. It's not are they connected by a line. It's could they be connected by a line. So are A and C collinear? The answer is yes, they are. The line wasn't drawn before, right? I can undo that. The line is not drawn right now, but it does not have to be drawn to exist. So we would say A and C are, in fact, collinear. They can and they do share a line together. We just have to draw it for us to be able to see it. How about B and C? Are B and C collinear? Yes. Yes, they are. There's no 2 points in the universe that are non-collinear. Collinear points, in order to be non-collinear, you have to have at least 3 points. So looking at this picture, if I said our points A, B, and C collinear, so as a group, as a collective, are points A, B, and C collinear? That answer has to be no. I cannot connect A, B, and C with a single line as is. So it takes at least 3 points before you can even consider non-collinear. Now, how many points can be collinear? Well, the answer is infinite. How many points could I put on a line together? Look at this. How many points are on this line? I could keep doing it forever. All of those are on a line together, right? They are all collinear, and I could do that in any direction. That line's determined by C, so I kind of focus through C. So 2 points have to be collinear. 3 points do not have to be collinear. They can, though. There's only 2 options that you can have with 3 points. If you have 3 points, one of the options is you have 3 points that do form a line. So those 3 points would be collinear points. The other option with 3 points is that they do not form a line, but instead they form a triangle. Those are not collinear. It's called non-collinear. So that's the only choices. So 3 points. So if I said sometimes, always, or never, 3 points are collinear. You would have to say sometimes. They can be collinear, but they don't have to be. Whew, some good stuff here. So it takes 2 points to determine a line. It takes 3 points to even consider non-collinear. Let's talk about planes now. Oops, I did the wrong button. So let's talk about planes. Let's talk about planes, baby. So we're starting fresh a little bit. That gray plane, I put a point on it. I'm going to put point B over there. I'm going to put point C over there. And I'm going to take point C and I'm going to move it up. So we can kind of tell if I rotate it, yeah, A and B are on the gray plane, point C is above it. So planes are just flat surfaces that extend forever. Lines extend forever in 2 directions. Planes are flat surfaces that extend forever. So even though they stop drawing the gray plane, it technically keeps going forever. Now, is point C on that gray plane? No, it's not. So let's ask a few questions. Are points A and C collinear? Yes. Doesn't matter. Any 2 points, they're going to be collinear. Are A, B, and C collinear? No. A, B, and C form a triangle, not a line. But are A, B, and C coplanar? What is coplanar? Coplanar means they're on the same plane together. Are A, B, and C on a plane together? Man, that's a tough one. They're not on the gray plane together. We can see that. C is above the gray plane. But are they on any planes together? That's the question. The answer is yes. So I can make a plane through 3 points, A, B, and C. Was the plane drawn? No, it wasn't. But remember, a plane is just a flat surface. So you have to picture, okay, can I draw a flat surface that connects A, B, and C? Is a triangle a flat surface? Yes, it is. If you can draw a triangle connecting any 3 points, then those 3 points have to be on a plane together. They're just on a different plane than the one that was drawn. And there are infinite planes in this picture. They're just not all drawn. The only one they drew for us was the gray one. All right, I'm going to draw real quick. I'm going to draw a line connecting A and B. Where do the planes hit each other? Look at the blue plane and the gray plane. Isn't it that line AB? So one of the things you need to know is that when 2 planes intersect, they form a line. They form a line. And how many planes can go through any given line? Ooh, this gets really tough. I'm going to move point C. As I move point C, does it change the planes? Every time it moves, is that a new plane? The answer is yes. Every time it changes even slightly, that's a different plane than the one before. So keep asking the program to draw different planes. As I move point C, it's constantly drawing different planes. And I can move it up and down. It's almost like if that black line was a spine of a book, it's like all the pages around the spine of the book. Each page represents a different plane. So every time I move point C, I'm representing a different plane. I'm not going to draw a million different planes, but it keeps representing different planes. So how many planes hit the line AB? Well, right now we can see 2, right? The gray one and the blue one both hit it. But if I move C slightly, that's a different plane, different plane, different plane, different plane, different plane, different plane, different plane. Every time I move point C, that's technically a different plane, guys. Different plane, different plane, different plane, different plane. That is infinite planes. Infinite planes go through that line. So the answer is infinite planes go through a given line. So we've talked about a little bit here. A, B, and C are non-collinear. You cannot connect A to B to C with a line. A, B, and C are coplanar. Can you connect 3 points with a plane? Yes, you can. So going back to what we said before, there's two choices. You can draw 3 points in a line or draw 3 points in a triangle. How many planes hit those 3 points? So if I have a line, draw it fresh a little bit. If I have point A, point B, and point C, how many planes hit those 3 points? The answer is infinite. Infinite planes hit A, B, and C. What if I can figure it a different way? What if I'd make a triangle? What if I have, we'll call it D, E, and F? How many planes hit all 3 points D, E, and F? That answer is one flat surface. So infinite planes hit a line, only one plane hits a triangle. Are A, B, and C coplanar? Yeah, all coplanar means is that they are on a plane together. Are D, E, and F coplanar? Yes. But here's where it gets tricky, guys. There's a big difference between coplanar. All coplanar means is they are contained on a plane together. That's it. Determine a plane means that exactly one plane hits them. Ooh, that's a big difference. A, B, and C are coplanar, but they do not determine a plane. If I said plane A, B, C, that doesn't mean anything. There's infinite choices. I can hit this line with infinite planes from infinite directions. I showed you that in the other program. But if I said plane D, E, F, there's only one plane that hits all 3 of those. So do D, E, and F determine a plane? Yes, they do. Are they coplanar? Yes, they are. Are A, B, and C coplanar? Yes, they are. Do they determine a plane? No, they don't. How many planes hit A, B, and C? Infinite. If I said plane A, B, C, do you know which one I'm talking about? No, you don't. But if I said plane D, E, F, do you know which one I'm talking about? Yes, you do, because they determine a plane. There's only one plane that hits 3 points that form a triangle. All right, so we know what collinear means. We know what coplanar means. We know the difference between coplanar and determining a plane. These are some big ideas. You're going to have to keep working at it to understand it. You got to keep visualizing the different situations. There might be a little bit more to this as we keep working through the unit, but these are the basic ideas.